Problems in fluids. 1. Problem number 4. The diaphragm for human breathing functions if the pressure difference between the outside of the lungs and the inside of the lungs is as much as 1/20th of an atmosphere of pressure. Suppose a diver breathes through a long snorkel that is a long tube rising above the water. How deep can a diver go and still breathe? Assume this is salt water with a density of 1.03 grams per cubic centimeter. So here's the top of the water. Here's the snorkel. The pressure outside is 1 atmosphere. And here are the lungs of the diver. And they can tolerate 1/20th of an atmosphere of pressure. At this depth, what is the pressure that's being exerted on the lungs of our diver? Well, the pressure being exerted is the pressure of the water at that depth plus the atmospheric pressure above. We would like for the pressure inside the lungs, in order for him to breathe, to be the same thing as it was when he was outside the water, which would have been 1 atmosphere. So what we have is the pressure outside, while he's a diver, the pressure outside right here is the pressure of the water plus the pressure of the atmosphere. And the problem tells us the difference between that and what he would normally breathe has to be equal to 1/20th the pressure of an atmosphere. So these two numbers cancel out, and so we're saying the pressure of the water has to be equal to 1/20th of an atmospheric pressure. Understanding this problem, what it just said, is the most difficult part. The pressure of the water, then, is rho times G times H, and that would be equal to 1/20th the pressure of the atmosphere. So I solve for H, which is the height, the depth of the water, the height of the water above the diver, and that's 1/20th of an atmosphere divided by G times rho. So I have 1/20th. Pressure of an atmosphere is 101.3 times 10 cubed. Kilopascals, 10 cubed, newtons per square meter. G is 9.8 meters per second squared. And rho is 1,025 kilograms per cubic meter. That is equal to 0.5 meters. Numerically, that's the correct answer, but logically it seems that's awfully shallow. It's only about 1.5 feet under the water, and snorkel tubes are very short. Clearly, if you went down a distance of 10 meters, you would develop 1 atmosphere of pressure from the water, if that were 10 meters, and then you couldn't breathe at all because the pressure outside and inside would be equal. But it seems that 0.5 meter is a little wimpy. Nevertheless, that is what the problem shows.